Good evening, everyone. My name is Pranav, and I am studying in Institute of Aeronautical Engineering, which is also known as IARE, BTech first year, second semester in CSC AIML branch. Today, I am going to talk about one of my most important subject and topic: how do you identify the proper wire gauge for a given circuit load? Coming to the introduction, in electrical systems, wires are used to carry electrical current from the power source to different electrical devices. The size of the wire is used in circuit is very important for safe and efficient operation. If the wire gauge is too small for the circuit load, the wire may carry more current than it can safely handle. This can lead to overheating, insulation damage, or even electrical fires. On the other hand, using a wire that is unnecessarily thick may increase the cost of installation. Therefore, identifying the correct wire gauge based on circuit load is essential for both safety and efficiency. So, coming to this, what is wire gauge? Wire gauge refers to the diameter or thickness of an electrical conductor. It determines the amount of electric current that a wire can safely carry without overheating. Wire gauges are usually measured using standard systems such as American wire gauge, which is also known as AWG system. In this system, smaller gauge numbers represent thicker wires, while larger gauge numbers represent thinner wires. Thicker wires can carry higher currents because they have lower electrical resistance. So, what is important in selecting proper wire gauge? We'll see. Selecting the proper wire gauge is essential for the safe functioning of electrical circuits. If the wire is too thin for the load, it may overheat due to excessive current flow. Overheating can damage the wire insulation and may lead to short circuits or fire hazards. Proper wire seizing helps to prevent such dangerous situations. Correct wire gauge also ensures efficient power transmission and reduces energy loss systems. Factors that affect wire gauge selection are: there are several factors you must consider while selecting proper wire gauge for a circuit. These factors include current carrying capacity, length of the wire, type of insulation material, ambient temperature, acceptable voltage drop. Considering all these factors helps engineers determine the safest and most efficient wire size for a particular circuit. So the current carrying capacity, which is also known as ampacity, it is the maximum amount of electrical current that a wire can safely carry without exceeding its temperature limit. Each wire gauge has a specific ampacity rating based on its size, insulation type, and installation conditions. If the current flowing through the wire exceeds its ampacity, the wire may heat up and damage the insulation. Therefore, when selecting a wire gauge, the wire must always have current rating higher than expected current load. So, what is the role of circuit load in this? Circuit load refers to the total electrical power consumed by devices connected to the circuit. Determining the load is an important step in selecting the correct wire size. To calculate the required current, electrical formulas are used. For example, current I equal to power P by voltage V. By calculating the current required for the circuit, engineers can choose wire gauge that safely carries the amount of current. So the effect of wire length is the length of the wire also plays an important role in wire gauge selection. As the wire length increases, the electrical resistance also increases. Higher resistance can cause voltage drop along the wire. This means that the voltage reaching the electrical devices becomes lower than the supply voltage. To reduce voltage drop in long circuits, thicker wires with low resistance are often used. So coming to the temperature and insulation type, environmental temperature and insulation types significantly affect the performance and safety of electrical wires. When the surrounding temperature is high, the ability of a wire to carry current safely decreases. If a wire operates above its temperature limit, the insulation may weaken or melt, which can lead to short circuits or electrical hazards. Different insulation materials such as PVC, rubber, and X-Leaf are designed to withstand different temperature ranges. Selecting wires with suitable insulation ensures that they can operate safely under specific environmental conditions. So the wire gauge standards are used to classify the wires based on their diameter and current carrying capacity. One of the most commonly used systems in the American wire gauge AWG standard. In this AWG system, the smaller gauge numbers indicates thicker wire that can carry higher currents, while larger gauge numbers indicate thinner wires. Electrical engineers refers to standard wire gauge tables that specify current ratings for different wire sizes. These tables helps in selecting the most appropriate wire gauge for a particular electrical load. So coming to the example, we see that for a wire gauge selection, consider a circuit opening is 230 volts and supplying a load of 2300 watts using the electrical formula, which is power by voltage, which is 2300, which is power by the voltage, which is 230, is equal to 10 amperes. This means the wire used in the circuit must safely carry more than 10 amperes. Engineers then refer to the wire gauge tables to choose a wire size that can safely handle this current without overheating. So, coming to the safety considerations, safety is one of the most important factors when selecting wire gauge for electrical circuits. Using wires that are too small for the circuit load may cause excessive heating and damage to insulation. Such overheating can increase the risk of electrical fires and equipment failures. To ensure safely protective devices such as circuit breakers and fuses are installed to prevent excessive current flow. Following electrical standards and safety codes also help to maintain the safe electrical installations. So coming to in the practical applications, proper wire gauge selection is essential in many real-world electrical applications. It is widely used in essential wiring systems to safely supply electricity to homes and buildings. Industrial electrical systems also require proper wire sealing to operate machines and equipment efficiently. Correct wire selection is also important in electronic devices, power distribution systems, and electrical appliances to ensure reliable performance and safety. So the importance of this proper wire installation is, in addition to selecting the correct wire gauge, proper installation of wires is also important. Poor installation practices may affect the performance and safety of electrical circuits. Wires should be installed according to electrical codes and should be properly insulated and protected. Proper routing, insulation, and connective of wires help reduce the chances of electrical faults and improve the reliability of electrical systems. So the wire gauge and selection steps are to identify the correct wire gauge for a circuit. A systematic process is usually followed. First, determine the total electrical load connected to the circuit. Then calculate the required current using electrical formulas. After calculating the current, refer to the standard wire gauge tables to find such wire that can safely carry the amount of current. Additional factors such as wire length, temperature, and insulation must also be considered. So, coming to the voltage drop consideration, voltage drop is an important factor that must be considered when selecting the proper wire gauge for a circuit. As electrical current flows through a conductor, some amount of energy is lost due to the resistance of the wire. If the wire is too long or too thin, the resistance increases and a noticeable voltage drop may occur. This means that the voltage reaching electrical device becomes lower than the supply voltage. Excessive voltage drop can reduce the efficiency and performance of electrical equipment. To avoid this problem, thicker wires with lower resistance are often selected for long distance circuits. So the common wire gauge sizes used in circuits are different, like uh, are used in depending the amount of current required in a circuit. So as we talked earlier, smaller loads generally use thinner, and while larger loads require thicker wire to carry safety. For example, if you take 14 and 12 AWG wires are commonly used in residential wiring or lighting systems and small electrical appliances. For circuits that require higher current, such as air conditioners or heavy equipment, thicker wires like 10 AWG or 8 AWG may be used. Selecting the appropriate wire size ensures safe current flow and prevents overheating. Coming to the conclusion, selecting the proper wire gauge is crucial step in designing safe and efficient electrical circuits. Incorrect wire sizing can lead to overheating, energy loss, and potential electrical hazards. Engineers must carefully evaluate several factors such as current load, wire length, voltage drop, temperature conditions, and insulation type before choosing the appropriate wire size. By following standard wire gauge tables and electric safety guidelines, reliable and efficient electrical installations can be achieved while reducing the risk or accidents in electrical systems. Thank you.